In part 3 of section 17, we're going to discuss a effective way for verifying that two functions are in fact inverses of each other. In example 17.2, we looked at a cube root function and a cubic function, and we saw three really important observations about them. One in particular had to do with the composition of those two functions. And the observation was that all of the operations canceled out, eventually leaving us with just x. That was not a coincidence. That is something that happens anytime you have two functions that are inverses of each other. And there's a theorem that backs us up on that. Theorem 17.2 is called the inverse function property. It says let f be a one-to-one function where the domain of f is a and the range of f is b. Again, this means that f takes a and maps it over to b. And then the inverse function, known as f inverse, is going to satisfy the following cancellation properties. Now, just as a reminder from the definition for the inverse then has to take the range and map it to the domain, which really means that b is now the domain and a is now the range. So you have to switch the role of the domain and the range. And then the compositions, f inverse of f will equal x, and then also f of f inverse will also equal x. But when we're talking about f inverse of f of x, then we have to think about the domain for f of x, which is going to be a. When we're talking about f of f inverse, we have to be thinking about what is the domain for f inverse, which is going to be b. So again, not a coincidence that all that cancellation occurred. That will happen every time you have inverses. So that's a really effective way to be able to verify that two functions are in fact inverses of each other. So let's look at example 17.4. It says, find f of g of x and g of f of x and determine whether the pair of functions f and g are inverses of each other. It's very straightforward. It says, find f of g of x. So let's go ahead and find f of g of x. This is going to be f of x minus 8 over 3, which is going to be 3 times x minus 8 over 3 plus 8. And looking at the operations, there is a pair of operations that can be canceled. And the only pair that can be canceled would be the divide by 3 and the multiply by 3. That results in x minus 8 plus 8, which can now have the minus 8 and plus 8 canceled, leaving us with just x. So that means that we are well on our way to being able to prove that these are inverses of each other, but the inverse function property says that both statement 1 and 2 have to be satisfied. So now we want to go ahead and find g of f of x, the opposite of f of g of x in terms of the composition, and we want to check to see does that same cancellation occur, or maybe a similar cancellation will occur. Maybe not exactly the same, but similar. So this is going to be g of 3x plus 8, which is going to be 3x plus 8 minus 8 all divided by 3. And looking at these orders of operation, there is a cancellation that can be done with the plus 8 and the minus 8 to get 3x over 3, in which I can then cancel times 3 and divide by 3, and that gets us to x. So by conclusion, I can say, therefore, f and g are inverses of each other. Now it's interesting to notice that the order of the cancellation is the opposite as what we had with the first composition. In that first composition, we had the 3's cancel first, and then the 8's cancel second. And then just the opposite occurs with g of f of x. The 8's cancel first here, and then the 3's end up canceling second in this one. But either way, we were able to show that both compositions give us X, and therefore F and G are inverses of each other.